So in this part 2 video, I want to start off where we left off, and that is showing you this ANOVA table that gives us our source of variation, our sum of squares, degrees of freedom, mean squares, f-statistic, and p-value. And I annotated specifically what each row was, which is written here. So what we need to do is we now need to understand what our hypothesis statements are. The first one, the 8 treatment means are the same. The alternative, at least 2 of the 8 means are different. When I talk about the 8 means, I'm going to come back up here. The 8 means are the driver and brand A, driver brand B, driver brand C, driver brand D, and then the same for the 5-iron brand A, B, C, and D. Basically, these 8 combinations right here. The factors brand and club do not interact to affect mean distance. That's the second null hypothesis. Or the alternative hypothesis is the brand and club interact to affect mean distance. The third hypothesis, null hypothesis, is the factor A means are equal, and the alternative, at least 2 of the factor A means are different. And the fourth hypothesis, the factor B means are equal, and the alternative hypothesis, at least 2 of the factor B means are different. So what I've done here is I've taken this ANOVA table and I have inserted a line, and I've named it corrected total. And basically what I've done here, and I will delete the numbers and derive them again, but basically what we want is we want all the terms in this line less the error line, okay? So that will essentially be our model total. So it's going to be this row plus this row plus this row, and this is sum squares for everything but the error. Degree of freedom total is 1 plus 3 plus 3, and that's 7. Our mean sum square term is simply this corrected total divided by degree of freedom equals 7. Okay, so that's our mean square, sum square term, or mean square term for the model. Then our F statistic is equal to the mean sum of the total divided by our mean sum of the error. Okay, so our total, our F statistic, if you will, then for the model is 140, and then the p-value is equal to f dot dis dot right tail. 140 is our t-stat. We put our degree of freedom associated with the numerator, which is 7, and then the denominator, which is 24, and let's see here, I see I have a period where I should have a comma, and you can see my p-value is really, really small, much, much less than 0.05. What that means is we reject the null hypothesis at least 2 of the 8 treatment means differ. Okay, that's what that means. Then we go to the interaction line, okay, and we look at the p-value there, and we see it has a very low number. So we reject that null hypothesis and say that the brand and club interact to affect mean distance. In the effort of completeness, but perhaps a little redundant, we can investigate or examine the p-values for factor A means and factor B means. We reject them both. Again, the p-value is much less than 0.05, and we can say at least 2 of the clubs affect mean difference, And really what that's telling us is that there's a difference in a 5-iron and a driver, which is true. And then rejecting HO for factor B, which is the brands. At least 2 brand treatments are different. Again, redundant with this statement. That is how you do a two-way with replication, two-factor or two-factorial experiment. That concludes this video.